Rational equations. When we work with rational equations, you have to remember the rule that you cannot divide by zero. If you end up with zero in the denominator, you end up with an undefined value for x, or the variable. So when you're given a rational expression, you want to find what's going to create a zero in the denominator. And to do that, you're simply going to take whatever the denominator is and set it equal to 0. So in the first example, we have x minus 4 over x. Well, we want to know what's going to create a 0 in the denominator, so you'll take whatever's in the denominator and set it equal to 0. So in this case, we just have x in the denominator, and when we set x equal to 0, that's what the x value that would create an undefined in the denominator. So in this case, we would not be able to have a solution if x equaled 0. In the second example, we actually have an algebraic expression. So you would take that expression and you would set it equal to 0. And then you would solve for the variable, and in this case it would be x. And to solve here, we would subtract 1, and then we would divide through by 2, and we would find that when x is equal to a negative 1/2, if I would put that back into the variable x, into the rational expression, I would end up with 0 in the denominator. Therefore, we cannot have our x variable equal to negative 1/2. And when we're working with rational equations and we're solving for the variable, the first thing we need to do is find the value of x that would create an undefined solution. And that means whatever x value would create a 0 in the denominator. So in this case, we see that we have 3x in the denominator and we have x in the denominator. If I set them equal to 0, I'm going to find that whenever x is 0, I'm going to have 0 in the denominator, so therefore we would end up with an undefined solution. So I need to eliminate that value of x. So when I solve this, I cannot have my solution equal to 0. If I get a solution equal to 0, there would be no solution for this rational equation. So now I want to solve for the rational equation. And to solve for the rational equation, you want to first find the least common multiple, because we want to eliminate the rational equations and make it a standard equation. So to do that, you want to multiply the entire equation by the least common multiple. So you're looking at the denominators here and you're trying to find the least common multiple. And we have 3x in the denominator, we have 2 in a denominator, we have x in the denominator, and we have 3 in the denominator. So if I was to find the least common multiple, it's going to be 6x. 6x would be the least common multiple, or the least common denominator for this rational equation. Now I'm going to take that least common multiple and I'm going to multiply it to the entire equation, because I want to eliminate the rational equation and make it a standard equation. So to do this, I'm going to distribute that 6x to everything in the equation. And you're going to see when you do that distributing, you're going to end up with something that looks like this. And then you want to simplify piece by piece. So when you look at the first piece here, I have 6x times 2 over 3x. Now I'm going to simplify, and I see that 3x will go into 6x 2 times. And now I need to take that 2 and multiply it to the numerator, and in this case is 2, so I end up with 4. And I'm going to do this all the way through. So I have 6x times 1/2. I'm going to simplify, 2 goes into 6 3 times, and I'm left with the x. And then I take that 3x and I multiply it to the 1. And I'm left with 3 or plus 3x. I'm going to do that x goes into x once. I'm left with that 6. I take 6 and I multiply it to 4 and I get 24. And then I simplify the 3 into 6, and I'm left with 2x. And I take 2x and I multiply it to 4, and I get 8x. Now I have an equation that I can solve. This is a multi-step equation. You're going to get the variables to one side. It doesn't matter which side you choose. I'm going to move that 3x over by subtracting it from both sides, and I'm left with 4 equals 24 plus 4 or plus 5x. And now I'm going to subtract 24, and I get a negative 20 equals 5x. I divide through by 5, and I get my solution here is x equals a negative 4. So I'm just checking to make sure that the value that I found for this rational equation is not the value that it cannot be. So you see here, x cannot equal 0, so x equal negative 4 is a solution. Pause and try. So the first thing you're doing is finding the value that x cannot equal. And in this case, x cannot equal 0. Now I'm going to find the least common multiple. And in this case, the least common multiple is going to be 2x. I'm going to take that 2x and I'm going to multiply it to everything in that rational equation. Now I'm going to simplify, and you see that this x canceled. I'm left with 2 times 3. I get 6. And then I have plus 2 times 2x. Plus 2 times 2x is going to be plus 4x. Equals, and then the 2x's are going to cancel out, and I'm left with 5. And now I'm going to solve the equation, and you should end up with x equaling a negative 1/4. And you see here that x can equal negative 1/4, it just can't equal 0. This next example, you see that I have rational equation, but in the denominator I have an expression, and that expression is x minus 1. Now the first thing I want to do is find the value of x that would create a 0 in the denominator. And to do that, you would take x minus 1 and set it equal to 0 and solve for x. So you would end up finding that x cannot equal a positive 1. If I would take a positive 1 and substitute it into x, I would end up with 0 in the denominator. Now I want to eliminate the denominators by multiplying through with the least common multiple. And in this case, the least common multiple is that x minus 1. So I'm going to take that x minus 1 and I'm going to distribute it through the entire rational equation. And I'm going to end up with something that looks like this. X minus 1 times the 3x over x minus 1 plus 2 parentheses x minus 1. I'm going to end up with the distributive property. And then I have the x minus 1 times the 3 over x minus 1. So then you're going to simplify, and you're going to simplify the x minus 1's, and you're left with 3x. You're going to do the distributive property here with that 2 times the x minus 1, and you're going to end up with plus 2x minus 2. And then you see these x minus 1's cancel out, and you're left with equals 3. Now this is an equation you can solve. You're going to combine like terms. You end up with 5x minus 2 equals 3. You're going to move the 2 over. You end up with 5x equals 5. You divide through by 5, and you end up with x equaling 1. Now you're checking, can x equal 1? X equaling 1 is what is excluded. So x cannot equal 1. You solved the rational equation here, and you got that x equals 1. Therefore, for this rational equation, there would be no solution, because we would end up with an undefined value. So x can't equal 1. We got the solution to equal 1. So the answer in this case would be no solution. Pause and try. So first we're going to eliminate what x cannot equal. And in this case, x cannot equal 2. I'm going to multiply through by that x minus 2. Make sure you multiply it to everything. You're going to simplify. You're going to end up with the distributive property there. So when you do the distributive property, you're going to end up with your final answer equaling x equals a -2.